I'm Melanie from Airbnb, and I'm here to talk about how we develop Kubernetes services at Airbnb scale. But first off, who here knows about Airbnb? Hopefully you do. Airbnb is an online marketplace for sharing homes and experiences. So we operate in 81,000 cities, over 190 countries, and we have over 5 million homes on our platform. Recently, we launched Airbnb Collections, which helps business, family, or any other kind of traveler to find the right home for them. Our engineering team is constantly creating new products and businesses, and they need to be able to spin up new services quickly and reliably. So that's where I come in. I work as a software engineer on the service orchestration team at Airbnb, and our goal is to empower our engineers to create, maintain, and operate their own services. So about a year ago, I helped migrate our first critical production service to Kubernetes, and today, out of hundreds of services, almost 40% of them are in Kubernetes today. So that's really exciting. You can tell this photo was from before I started. I have a few gray hairs from that process. But I'm going to take us back to a brief history of Airbnb. So we've been transitioning from a monolithic to a microservices architecture. And so why microservices? We started to hit significant issues scaling contributions to our monolith in 2015. And our engineering team today is over 1,000 engineers. So that's kind of scary. And what we needed to do is we needed to scale continuous delivery horizontally. So each service gets its own continuous delivery cycle, and you can scale development for our engineers by adding new services. We managed to scale development exponentially at our size with a total of around 20,000 deploys per week. This means because we've both introduced exponentially more services and exponentially more environments for each service. So we actually have a suite of pre-production environments, think development, staging, load testing, canary, before changes go out to production. And by the way, each of these dips in this graph are for our holiday break right around now. So we don't allow deploys during this time because we don't want to ruin Christmas for our travelers. And our monolith deploy rate has leveled off as we've migrated logic to services. So I'm personally very excited by this graph. Collectively, we are on track for about 125,000 production deploys between all of our services per year. So how do we get to Kubernetes specifically? Because we actually started this journey before Kubernetes. So about a decade ago when we started as a company, we were just manually configuring boxes, so our configuration management system was not very evolved. Then we started to use Chef to configure our repos, and it was basically a monolithic configuration repo. Changes to one cookbook or recipe could inadvertently take down other services or environments, and there was no clear rollback story for our changes. And recently we moved to Kubernetes, which automates both the configuration and orchestration of containerized applications. So what does that get our team? So Kubernetes itself, the configuration is declarative. That's more resilient. There's less maintenance burden. Think about a certain instance having degraded hardware. Before, engineers had to go and manually launch a new instance. With that declarative configuration, you don't have to do that. Big one for us was efficient scheduling. It's just helping us save money. And with our history of having a lot of configuration, how do we actually integrate with Kubernetes? How do we migrate all of our services and infrastructure in a way that is compatible with Kubernetes? And having an extensible API really helps us with that. And then all of these features of Docker, portability, immutability, reproducibility. So before our infrastructure was mutable, that meant you could SSH into an instance and change something, and it could be like that forever. And so that resulted in some pretty interesting incidents. And reproducibility just makes it very easy for us to roll back to our previous version. And YAML is pretty human-friendly and robot-friendly compared to our previous infrastructure, so the standard format makes it easy for us to work with it. What are the challenges with Kubernetes? So the configuration and tooling are complex. There's open issues. Integrating with your current infrastructure can be challenging. But what I want to stress today is that these are all solvable problems, and that's what I'm going to talk about, is how we solve each one of these problems. Why generate Kubernetes files? So let's talk about the problem of having a bunch of bare metal Kubernetes files that you manually apply to the cluster. You handcraft these config files, and you manually apply them. They're artisanal, they're small batch, until you have a lot of environments. suddenly you actually kind of have this end-by-end grid of resources environments that has a lot of boilerplate and it's repetitive by environment. So this is actually, I couldn't fit all the environments we have on this one slide. So just imagine this even bigger. So our requirements for reducing boilerplate was we preferred templating over file inheritance, and that was because we learned the hard way that it was difficult for our engineers to visualize complex hierarchies with files. So we preferred templating for that reason. We wanted to have engineers to opt into higher level abstractions over Kubernetes files, but always have the option to use raw Kubernetes files if that's what they prefer. And finally, we wanted to make it easy to migrate hundreds of legacy services and retrain 1,000 engineers, which was kind of intimidating for us. So the solution we came up with was a bit of a custom solution that mapped Kubernetes concepts to legacy ones. We optionally supported Go templating, and our tools handled both Kubernetes files and the custom files. I just want to point out that this ecosystem is super rapidly evolving. So there's a bunch of things here: Helm, Customize, Capitan, whatever requirements you have, if you want to combine with package management, if you want to use file inheritance or templating, and even yesterday at Julia's talk about skyconfig, that's even another option if you want to configure this in your code directly. So I'm really excited about this space and excited to see what's coming out of it. So here's our internal abstraction on the left. These are all concepts that Airbnb engineers are familiar with, and we can generate them into valid Kubernetes files. So we call it KubeGen. And the important output here is this creates files. The generated Kubernetes files have standardized namespaces based on environments. So today's example service is Bonk, and our Bonk service has a few environments. Also, I couldn't fit them all on the screen. But like the important ones: Canary development, production, staging. And if you expand each of these subdirectories of generated files, those are all those Kubernetes files. So we have several config maps, services, role binding files, et cetera, et cetera. And it's going to be really powerful later on when I talk about our tooling, why having standardized namespaces is important. One other thing I wanted to call out is we noticed a problem where a lot of services were re-implementing the same exact code over and over again. So Nginx, tracing, statsd, logging, stuff like this, people are just re-implementing it over and over again. So we actually came up with a component framework that will merge YAML into your project. All these common patterns are abstracted into a component. You can require or set default params. So for Nginx, something like the default number of workers that you're dealing with. And this extensible framework also made it easy for us to model Airbnb-specific infrastructure and concerns as components, and like separate it from like our general solution. So the takeaways here are that you can reduce Kubernetes boilerplate, and you can standardize on environments and namespaces. So our internal abstraction has accelerated our migration effort, but we landed on a more powerful idea: generating service boilerplate. We founded our guiding principle, which is that everything about a service is in one place in Git and managed with one process. So I want to let that sink in, and I'm going to break it down. So everything about a service is in one place in Git. What does that mean? Lives in one place. Here's our Bonk service. So everything, in our case, lives in _infra alongside project code. We don't have a separate configuration monolith. We don't have a configuration monorepo. All of the configuration for your project lives right next to your project code. You can edit code and configuration in one pull request. And it's easy for us to add new configuration into the system. We're just supporting a new way of storing stuff in Git, which most developers are familiar with. And one thing I'm going to talk about in a bit is how we can actually have really good validation as part of integration and deploys. So we store all of our configuration in here, and it's a lot. And we're adding new stuff every single month. So this Hello World Service Bonk was created in one command. It took me about 30 seconds. It's a collection. So the way we generate services is a collection of config generators, like documentation generator, CI generator, Kubernetes generator, and a collection of framework-specific generators. So we have support for Rails, Dropwizard, and a few other frameworks. So by generating services for engineers, we make the best practices the default. So I talked about how almost 40% of our production-ready services are in Kubernetes. How did we get there that fast? So by making it really easy for service owners to create a new service in one command, like that's great. Like instead of spending 2 weeks handcrafting all this configuration that's just saying hello world, I literally type one command. So me, Melanie, the smart infrastructure engineer is like, how do we get people to use documentation? How do we get people to use auto-scaling? How do we enforce that people test their changes in a deployment pipeline or use our latest continuous integration? So I put it in the generator, and all of our services are using this stuff. It's so great, I love it. So you can run generators individually or as a group. So they run as a group for a new service. But what we really wanted to get here as well is the ability to constantly update and refactor services. So we use an open source framework called Thor, and it supports review, update, and commit. It's kind of like handling Git merge conflicts. And what I like about that is one other thing I want to talk about is we have hundreds of services in Kubernetes, right? And all of their configuration is in project code now. So if you decide that you want to completely change how you do continuous integration, you actually, how do you do that? So we actually have a refactor job. It's a Kubernetes cron job that if you can model and our configuration is versioned. So if you want to model going from one version to another, you can actually kick off a job that automatically migrates all services to your new thing. And so we actually use this generator for new services and for refactoring existing services. So everything about service should be in one place in Git and make best practices the default by generating configuration for your users. OK, so now that our configuration is streamlined, let's switch gears to another problem, which is interacting with kubectl. By the way, I call it kubectl. I don't know what the rest of you all do, but yeah. So yeah, I love this graph, by the way. I spent a lot of time on it. So we have our artisanal graph, right? Well, actually now it's more mass-produced because we're generating it for people. But we have lots of boilerplate. It's repetitive by environment. And kubectl apply, it's also a little verbose and repetitive by namespace. So kubectl commands actually, they're a little bit verbose, and even if you're a master at them, it still can be kind of complicated to construct the commands or just even move quickly with it. So we introduced duct tape. So this is the KTool. It's our all-purpose CLI wrapper. It's really easy to build one yourself. It's just a script. So our KTool, basically, we have a bonk service. We CD into our bonk service, and we type a command. The way it works is it takes environment variables for arguments. So kstatus env equals staging. And then it prints the actual command it's going to use. So this is just supposed to make it easier for developers. We're not trying to hide what's actually happening. So kstatus, for us, will get kubectl pods for your namespace. And remember when I said standardizing on namespaces is super awesome? So since we're in the bonk project directory and we pass in the env equals staging environment variable, KTool knows that you're operating in the bonk staging namespace. So we just saved people a few clicks. Especially, I don't know why this is, but a lot of people have really long service names. So we save a lot of those people time, too. So we also automate a few different commands. So kgenerate transforms our internal abstraction to Kubernetes files. Kbuild will do a project build, Docker build, and Docker push for you. And then kdeploy. Kdeploy will create a namespace, apply files, and then check the deployment status. So we wanted to simplify developers' iteration cycle. And for those of you who are lazy, we actually chain all these commands too. So a lot of our developers are just familiar with typing kall. So one other thing I wanted to get developers was basically just automating debugging flows. So we noticed that debugging Kubernetes services is actually a bit of a thought shift away from debugging other services. There's a bit of a learning curve, and how do we make it easier for people to debug? So for example, people were previously used to SSHing into instances. So we gave them a kssh command that basically does a kubectl exec bash for them. And if your service is crash looping, we just default to a random pod and a random container to figure out, just get me to why it's crashing, kind of. But But if you know there's a problem with a particular pod or a problem with a particular container, we support that too. So remember these environment variables. So we have a pod environment variable and a container environment variable. And then finally, we went even further with our kdiagnose command. So basically, kstatus gets our pods, and then for each unready container in our pod, for each of their states, we get the state and we get their logs and we output them. And then we also, so maybe it's a problem with one of your unready containers, or maybe there's a problem with the cluster, and it would be nice if a service owner could figure that out. So we also do kubectl get events, we get the pod, and we filter any normal events. So we're trying to give developers the abnormal events. So kdiagnose will tell you if there's something wrong with your pod, any of the containers in your pod, any problems with the cluster. So even if you're like, wow, I'm a kubectl wizard, I mean, that's pretty cool. Like, that's stuff that I know a lot of people do manually all the time. So it's really great to just automate that for yourself. So create a wrapper for kubectl commands and automate those common K8s workflows, whether it's building, deploying, debugging, SSHing indicators, et cetera. Now that we've stored all of our code in one place and built the KTool, let's see what we can provide as part of CI. So all of our projects get validation, they get a build, and they get build docs. So our validation actually checks for malformed YAML, checks for security problems, checks for required configuration, like if we want to require project ownership, we can do that. So the way we do it is each step in our CICD jobs is just run steps in a build Docker file, and it runs the K commands. What I really like about this is it's super transparent to developers when any of the K steps fail, they're familiar with those because they use them in development. They also use the KTool when there's like a production incident and they're trying to figure out what's happening to my production pod. So they're using the same K commands, the same exact interface is used in every possible environment they can work with. And that's really important when developers are like under fire with an incident. So the takeaways here are that CI/CD should be the same commands engineers run locally, and it should run in a container or otherwise be abstracted away from the infrastructure it's running on. And you should validate configuration as CI/CD. And we also use an admission controller to like validate as part of CD. So with all of our code configurations stored in one place, it becomes possible to deploy them together as part of the same deploy process. So hopefully as a developer, you're kind of familiar with this flow, develop, merge, and deploy. So I'm going to talk about both Kubernetes files and custom infrastructure files. How do we apply them to the cluster? So I said kubectl apply, but I was actually lying to you. We don't actually just do that. So our deploy process is we first try to kubectl apply all files. We know that there's actually some well-documented cases where apply will fail, but replace without force will work, and vice versa. So then if that doesn't work, we'll try kubectl replace without force. And we always restart pods on deploy to pick up changes. Finally, we try to return an atomic success or failure state by sleeping and checking the status. So services in crash loop will actually eventually time out, which is a helpful indication to our users who aren't used to services in crash loop backoff that there's something wrong with their deploy. So I mentioned, how do we always restart pods on deploy? So why do this? We found that there were some issues where you applied a configuration change, and it wasn't really applied to pods until later. So like there was like enough time. It's like training a dog. You want there to be like a really short iteration between like, oh no, something bad happened or something good happened. So for us, we always apply our configuration and restart our pods to pick it up immediately. So we have that immediate feedback. And the way we do that, just a quick trick, we add a date label to the pod spec. And then custom configuration, just going to click through this really fast. So we have a bunch of custom configuration. The way we do it, custom resource, custom controller that calls a webhook, and then the actual webhook itself that updates a custom resource. So you can actually hear more about custom controllers later today with my coworkers talk, Custom Controllers to the Rescue with Stephen and Davi in like an hour or two. And this is really exciting. So like in this case, our infrastructure engineers just need to supply a webhook to apply their kind of file. So if a service needs a new IAM role, the AWS.YAML custom controller webhook will actually call a Lambda function that will apply it to our AWS account. So code and configuration should be deployed with the same process. and use custom resources and custom controllers to integrate Kubernetes with your infra. So I want to leave you with the 10 takeaways I was going through if I clicked through too fast. So reduce Kubernetes boilerplate. You want to abstract Kubernetes files from your developers. Standardize on environments and namespaces. We saw how useful that was with our tooling. And everything about a service should be in one place in Git, both the code and the configuration. We want to make the best practices the default by generating configuration. And one thing I want to add on here is the support for update for refactoring. Create a wrapper for kubectl commands, and then automate common case flows with that wrapper. CICD should run the same commands engineers run locally in a container. Validate configuration as part of both CI and CD. Code and configuration should be deployed with the same process. And take advantage of how Kubernetes builds extensibility into its platform with custom resources and custom controllers. Cool, so thank you for that. I have so much more I'd love to talk about this, but I'm out of time. So you can learn more at our Medium page. We're hiring in so many places. I'm repping my Airbnb Seattle shirt, so we're hiring a lot in Seattle. We have offices in San Francisco, Beijing, and all over the world. So please apply if you're interested, and you can reach me directly at Melanie Cebula on Twitter.